The story of how Charles Darwin came up with his idea about evolution by natural selection has been told thousands of times. The life-changing voyage of the Beagle and the visit to the Galapagos Islands. His triumphant return to England after a 2-year mission stretched to a 5-year circumnavigation of the world. And the celebration of the scientific cornucopia he brought back with him. The long years of self-isolation at Down House, south of London, where he painstakingly worked through his developing thoughts about evolution and how it worked. The near scoop presented by Alfred Russel Wallace's own independent formulation of the theory of natural selection. And the scramble by Darwin and his friends to do the right thing by both Wallace and Darwin. If this were to be a conventional treatment of evolution, we would cover all those things in scrupulous, no, scrumptious detail. But as I have said, it's not my intention to be conventional. What I would like to do in this episode is to go through some of the elements of Charles Darwin's own thinking that led him to his idea of natural selection. There's a curious thing lurking in there. He built his theory on error. We'll take that up in the next episode. Before going any further, there's an important point I want to make. I am a frank admirer of Charles Darwin. Everyone should be, in fact. When he returned from his voyage on the Beagle, he instantly became a celebrity in the scientific circles of London and England. The collections of animals and plants he sent back periodically were immense contributions to the museums and the universities of England. His geological observations on earthquakes and their aftermaths were groundbreaking confirmation of James Hutton's claims of a gradually changing and immensely old Earth. He made important contributions to the origins of coral atolls, which, at the time, were mysterious fairy circles to most. He catalogued new creatures that were unknown to his contemporaries in England and Europe. His notes on variation of species, in particular the variation between the various islands of the Galapagos archipelago, were penetrating and insightful. In short, Darwin was a superb naturalist and a meticulous observer of the natural world. He's famous because he deserves to be. Not having any need to earn an income, thanks to the wealth of both his and Emma's families, the Darwins were able to retire to a life in seclusion in the village of Down, a few miles south of London. There, he occupied his time with a close observation of nature, correspondence with fellow scientists, and little experiments here and there. In short, he lived the life of the parson naturalist he wanted to become, but without any obligations to church or flock. For example, he wrote what is still the definitive work on the biology of barnacles. He made important observations on pollination, and in particular on the contrivances of orchids to ensure fertilization. His books are packed with exquisite detail of peculiar adaptations and speculations about how these came to be. Once he and Emma moved to Down and started building their family, Darwin began writing down his emerging thoughts on evolution and the origins of species. Pretty soon, within a few years, he had the elements worked out for his theory of evolution through natural selection. He held back on sharing his theory, though, because he wanted to present the world with an irrefutable case. There would be no Lamarckian speculation for him. And Charles would not be brashly putting his theories out there like his grandfather had. So he spent roughly the next 20 years working up the voluminous tome that he hoped would convince everyone that he had solved the problem of evolution. And then, in February of 1858, a short manuscript arrived in the mail from an obscure fellow naturalist, Alfred Russel Wallace, who was then collecting specimens of plants and animals on one of the many small islands in the Malay archipelago. In his manuscript, Wallace laid out in a few short pages the essence of his own theory for how species evolved. His manuscript was titled "On the Tendency of Varieties to Depart Indefinitely from the Original Type." Wallace's theory, which he later recounted as coming to him in the throes of a malarial fever, was essentially the same theory, spelled out in a few paragraphs, that Charles Darwin had spent years working on. Darwin was shattered by Wallace's manuscript. He was convinced that Wallace had scooped him, and that his 20 years painstaking work in preparing his book would be but a postscript to Wallace. This set off a scramble by Darwin's friends to ensure that not only would Darwin get the credit he deserved, but that Wallace would also. Part of that solution was for Darwin to write what he called his abstract of his theory, which was the book titled The Origin of Species by Natural Selection, or The Preservation of Favored Races in the Struggle for Life, what we now know simply as The Origin of Species. At nearly 500 pages, it was anything but an abstract, but it did the job. Evolution is now synonymous with Darwin. Wallace is still recognized, of course, but he has fallen into relative obscurity. We'll take up him in a later episode. Darwin never wrote his great work. Thank heavens for that. It likely would have been unreadable, nor would it have had nearly the impact his abstract did. We have Wallace's prod, as well as Wallace's own modesty and generosity to thank for that. In The Origin of Species, Darwin laid out three broad arguments for his theory, each backed up with voluminous observational detail. His first argument was to enlarge on what is meant by species. The concept of species is essentially one of classification. Let's compare, for example, two species of birds, the Baltimore oriole, Icterus glabra, and the scarlet tanager, Pyranga olivacea. Both are showy birds with striking orange and black plumage. You can reliably distinguish one species from the other through various sets of attributes. The scarlet tanager has a red head, for example, while the Baltimore oriole has a black head. To Darwin, this categorical approach to species missed an important point. The tanagers and orioles are different genera, but within a genus, say the orioles, there is also variation in plumage color. Some might have brighter plumage than others, or slight differences in the patterns of coloration. If these affected the likelihood of breeding, evolution into species with distinct colorations can be the result. To support his argument, Darwin pointed to variation among domestic animals and selective breeding as an important example of this, showing how, for example, different types of dogs or pigeons could be brought about by selective breeding. He went on to show that similar variation existed among plants and animals in the wild. New species could originate, Darwin asserted, if there was a process of natural selection that was similar to the artificial selection employed by breeders of domestic plants and animals. But what could that process be? Darwin puzzled for a long time over what could produce such a natural selection. By Darwin's own account, the pieces of the puzzle fell into place for him in 1838, when he took up a book, for amusement, as he put it, by this man, Thomas Malthus. The book was Malthus's 1798 book, an essay on the principle of population. Thomas Malthus was a British economist and demographer. At the time he was working, the Industrial Revolution was seriously underway, along with all its attendant social disruptions. At the time, England was reforming its social welfare programs, the so-called Poor Laws, which sought to provide aid to the poor, indigent, and unemployed. Malthus argued that such aid was misguided, and he based his argument on a very specific mathematical proof. And here is his proof, in the form of a graph of change through time, comparing population growth and the resources needed to sustain it. Let's start with population. Malthus argued that populations increased geometrically over time, what we today would call exponentially. In such a trend, population would double, then quadruple, then octuple, and so on. Malthus figured that the doubling time for human populations was about every 25 years. Populations have to be sustained, however, with food, water, and shelter, what was supposedly lacking and what the Poor Laws were intended to mitigate. Malthus argued that sustenance, measured, say, by agricultural production, could only grow arithmetically. Today, we would call this a linear increase. Malthus's proof was that populations would inevitably grow to exceed the ability to sustain them. At first, food, water, and shelter might be abundant compared to the population that had to be supported, but as time went on, a geometrically increasing population would exceed the ability to sustain it. The inevitable result would be a struggle for existence. This was the argument that caught Darwin's eye. Surely a similar struggle for existence would prevail in nature. And surely the winners would be those variants that could prevail in the ongoing struggle for existence. If natural selection operated, Darwin was convinced that evolutionary change would have to be slow and gradual. In this, he was very strongly influenced by James Hutton, who we have already mentioned for his ideas of ongoing and gradual change of landscapes and geology. In committing himself to such a gradualist view, Darwin was also reacting against claims for the pace of evolution that had been made by Georges Cuvier. You'll remember that Cuvier regarded evolution as proceeding through relatively short-term catastrophes, as he called them, interspersed with long periods of no or little change of biota over time. Here's the diagram from The Origin of Species which Darwin used to illustrate his idea. Each horizontal line represents an enormous number of generations. He said in the text that the space between the lines could represent 1,000 generations, although he claimed it could as easily be 10,000 generations. You can see his idea. Starting from an ancestral genus, let's say the one marked A, over generations, forms would diverge from the ancestral type. Most of these would go extinct, but over time, the divergence would become great enough for new species to arise. 3 in this hypothetical case, species A in red, species F in green, and species M in blue. Note how all are bound to the ancestral genus through their common living filament, in Erasmus Darwin's words, even in lineages that go extinct. You can trace a continuous line from anywhere in this tree to any other branch. These 3 elements, variation of form, competition of these various forms in the struggle for existence, and the resulting gradual diversification of form over time, formed the elements of Darwin's theory for the origin of species through natural selection. The beauty of this idea was that evolution could work as a sort of machine. Turn the crank, and new species, endless forms, most beautiful, as Darwin put it, would be produced, essentially automatically. No strange vitalist forces would be required. It would be as automatic and law-driven as the motions of the planets. Darwin would spend the next 20 years building the case to support his argument. The Origin of Species, prodded by Wallace, would be the result. It was a remarkable synthesis and a great intellectual achievement, to be sure. There was just one problem. All 3 of these elements were, to varying degrees, either false or had to fall back on the very thinking that Darwin was determined to overthrow.